Chapter 7, Lesson 4, Solving Logarithmic Equations and Inequalities. So here's the key here. Logarithmic equation, an equation that contains one or more logarithms. So we're going to take what's called the loop method to solve this logarithmic equation. So solving these equations. So again, I'm just rewriting them. So I'm taking, again, if we rewrite this, we have base is 36, exponent 3/2 equals x. Now I can plug that into my calculator. 36 to the 3/2 x is going to equal 216. So rewrite it. We should be able to plug this into our calculator then to solve. So log 9 of x equals 3/2. Again, if I rewrite this, it's 9 base 9 exponent 3/2 equals x. So then x again is going to, when I plug that in my calculator, x equals 27. And the last one here, base is 16 exponent 5/2. So if I plug that in my calculator again, or you can think about it, square root of 16 is 4, 4 to the 5th power, going to be a big number. X equals 1024. So just rewriting them, and because I rewrite them, now I can plug them into my calculator. Okay? But again, remember, calculator logs are base 10. Okay? Not base 36, not base 9, not base 16. Okay? Property of equality for logarithm functions. So if b is a positive number other than 1, okay, then we can say this, and then log b of x equals log b of y, if and only if x equals y. So if log the bases are the same, then I can say that the two parts are equal to each other. So for example here I have log 5 of x equals log 5 of 8. Therefore x then has to equal 8. Okay? So same idea here. Again, if these logs are the same, which they are, I then can say x squared minus 4 equals 3x. So again, if I have x squares, I need to get everything on the same side. Set that thing equal to 0. So we're going to subtract this 3x. So I have x squared minus 3x minus 4 equals 0. And so remember, now we're solving for quadratics. So a couple things you can do. You can factor, okay, which is what we're going to do here in this case. So I can factor this. X's are in the front. Factors of 4, 1 and 4, 2 and 2. So it has to be 1 and 4. To give me a negative 4, it has to be 1 positive, 1 negative, and then 4 has to be negative. To give me a negative 3 with a positive 1. So then to solve, again, set each of those equal to 0. So now I can take x plus 1 equals 0, so x equals negative 1. And I can take x minus 4 equals 0, so then x equals a positive 4. So two solutions there for those problems. And part B, same thing. I'm looking here. I have these log base 3's, those are the same, so I can say x squared minus 15 equals 5x. Again, x squared, so let's get everything on the same side. So subtract this 5x over. So x squared minus 5x minus 15. That equals 0. Now I can't really factor this one, so again I got a couple other options. Quadratic formula is one of them. So by doing my quadratic formula, opposite of b, 5 plus minus square root b squared negative 5 squared minus 4 times a, 1 times c negative 15, all divided by 2 times a, which is 1. So I'm just plugging that into my calculator, getting my values here. So this is 5 plus minus square root. Inside that square root gives me 85. 85 does not simplify down, over 2. And you can do it just like that. I'm okay with this. Again, if you want to plug it in, to a calculator to get decimals, you can hit something like negative 2.11 and 7.11. Or if we're graphing, we could graph it and we get those decimals with the graphs as well. Okay. Those were equations. Now, logarithmic inequalities. So an inequality that involves logarithm. Now there's two options here. Okay? So if the log is greater than the value, then x is greater than the exponent. Okay? If the log is less than, then x is going to be greater than 0 but less than the exponent. Okay? So here I have x greater than, or log 4 of x is greater than or equal to 3. So x is going to be greater than or equal to, and when I rewrite this log, it's 4 with an exponent of 3. So x greater than or equal to 4 to the 3rd power, okay, gives me 64, so x greater than or equal to 64. Second one here is going to look at my second bullet point here. Log base 2 of x is less than 4. So again, I'm looking at this. So 0 less than equal to x, which is less than equal to, now my exponent 2 exponent of 4. So I can then simplify that. 0, x is greater than or equal to 0, and 2 to the 4th power gives me 16, so less than 16. Last example here, so property of inequality of logarithms. So if b is greater than 1, okay, so my base here is greater than 1, then log b of x is greater than log b of y. So again, same logs here. What can I do? Well, then I can just set this inequality up, right? So if I get log bases are the same, I can just set my inequality up. So here we have log base 4, log base 4, so now I have x plus 3 greater than 2x plus 1, and we can solve. Let's get our x's on the same side. So 3 greater than x plus 1. Remember, all properties of inequalities here apply, so if I multiply or divide by a negative, I need to flip that sign. So 3 minus 1 gives me 2. So x is less than 2, or 2 is greater than x for letter A. Letter B, same idea. Again, log base 5s, those are the same. So I'm just taking those values in parentheses here. So 2x plus 1 less than equal to x plus 4. And now again I can solve, get my x's on the same side, so minus x. So 2 minus 1 is 1x. Subtract our 1 here, so x is less than equal to 3. Alright, so that's for lesson 4, chapter 7, lesson 4.